Hey guys, today we have some interactive notes. It's an activity that we're going to actually glue into our notes on system of equations, and we're going to match them up, the equation to the graph to the answer based on the notes that we took on Friday. So this is going to be page 62 in your notebook, and if you scroll over to that page now, mine is blank. We are going to title it and do this together. Systems of equations matching. So the worksheet that was attached today, if you are not able to print that out and cut it up, you can just write the letter and the number that goes with the solution. So the worksheet has graphs that are lettered, and then they have equations that are numbered. And so you can just write, 2A in whichever answer matches. So if you think 2 and A are both infinite solutions, you would write them in that. So you can just put the number and the letter in the answer that you think it matches up with. And you'll glue them, if you're gluing them into your notebook, you'll glue them into where each equation has a graph and an answer that matches. So going across, they would match up and work. And then you would do another row and another row. So you have 3 examples of equations, 3 examples of graphs, and 3 answers, and they just need to match up. So if you cut them and glue them out, you'll just upload a picture of your notes where they're all glued in together. And I'll do one of them with you so that you kind of have an idea of what is to be expected. All of the equations are in standard form, so you're going to have to do some math to figure out what that equation even looks like as a regular slope-intercept form equation, so you can see if it matches up with your graphs that you have. So for this first one, we can see that these are linear functions because the x value has no exponent on it, and it's just by itself attached to a slope, and we see that there's a y here. So looking at this, I can see based on the characteristics that this is a linear function. However, I want it to be in this format. So I need to get my y by itself, so I need to move everything away. So I would actually take that 2x to the other side, and I'm going to write above it since I don't have any room. And that would then be negative y equals negative 2x minus 1. When I move that 2x over, it becomes negative. And then to get rid of this negative, we know there's an imaginary 1 that's attached to that negative. We would just divide away the negative 1 and do that to everything. And that would then make our final equation y equals 2x plus 1. And remember the shortcut that we talked about early on. If you have negative y and there's no number over here besides the invisible 1 that's there, you can just flip all your signs. So negative y equals negative 2x minus 1 would all flip, and they would be positives. And so this is the same equation as this here. It's just in a much better format for us. And we're going to do the same thing to the bottom one as well. We're going to move that over, and we'll have y equals negative 3x plus 6. So now we have 2 slope-intercept form equations, and we can look at our graphs. And now what you want to do is you're looking for graphs that have 2x plus 1 and negative 3x plus 6 on them. So let's just look at C first. Well, we always start with our b. Remember, we begin with the b value. So this has a b value of positive 1. So do either one of these graphs start at positive 1? No. Nothing is actually touching positive 1. And the other b value is at positive 6. Again, there's no line at 6, and there's no line at 1. So this graph does not match up. We always start with that b value. So let's look at this one. Does one of these lines cross at positive 1? Well, this one does. And then, so we begin with the 1, and then do we have a slope of 2 over 1? Again, all whole numbers can be turned into a fraction by putting them over an imaginary 1. So from here, can we go up 2 over 1? Up 2 over 1. And it looks like it fits. So this line is this equation graphed. What about this line? For this bottom equation, we need to start at 6. Well, it does touch the 6. And then we need a slope of -3/1, right? So from here, do we go down 3 and over 1? Well, that seems to work. So these would match. These are the graphs that match these equations. And then, now that we can see them graphed, is this one solution, no solution, or infinite solutions? And remember, no solutions means there's no place where either graph will touch. One solution means there's one place they touch. And infinite solutions means they're the exact same equation and the exact same graph. And so since we can see that there's one place that these graphs are touching, our answer is going to be one solution. So I would glue these 3 down. And I might even color code them, squiggle them in a certain color so I know they're all together, or I can just box them all together up here. But these 3 go together. I would glue them in and do the same thing for all the others. I'd also like to add that when you glue this in and you upload a picture of your notes, I need to see this work on here. If there's nothing on here and then these are all just glued in, I'm going to ask you to show me your work from a separate sheet of paper, or you're not going to get credit. So I need to see that you know that these equations match these graphs because you've done the work. So this needs to be there. And that's all you have to do for today is work on these 3 problems and get them glued into your notebook.